Hi, I'm Michael von Schenk.
Gabriel Urdaneta.
Ebizimo Alagha.
Kyle Stapleton.
Here is the requirements for the third order Butterworth filter to the push-pull amplifier. Our input voltage total is the 1.1 voltage signal, or AC signal. That's what we found is the average auxiliary output for a cell phone. And the input frequency is anywhere between 20 to 20,000 hertz, which is, again, the average range for audible music, for just today's music. Input current is less than 10 milliamps. Let's see. Our relationship is the output gain. Gain is less than 2.5 for all frequencies, and the gain is greater than 1.0 for frequencies smaller than 620 rads per second, while gain is less than 0.1 frequencies for higher than 1600 rads per second. The requirements for the push-pull now is 2.2 voltage input, because the Butterworth has a gain of 2. With the current less than 10 milliamps, tolerance is plus or minus 200 millivolts peak to peak. And our output for the push-pull is our 8 ohm speaker, which is 20 watts, and the relationship up here is 2 times the input, and the tolerance is plus or minus 500 millivolts.
Okay, so on to our simulations. Here we have our third order Butterworth filter. And so we start with an AC source of 1.1 volts. Actually, that's the amplitude. Our peak to peak is 2.2 volts. The typical output for any iPhone. All right. And so what we have here is, we have calculations. What we ended up with is about 1600 ohms for each resistor. Up here we have a 1600 to 1600, so a 1-to-1 ratio. We want to keep that. The only thing we had to change was our initial op-amp. We had a Chebyshev filter. In order to correct this and make it a third order Butterworth, this first resistance we multiplied by 2.2 times the typical resistance that we've been using. Our output, we're keeping at 2.2 volts across. We chose an 8 ohm speaker, or at the end of this, the 8 ohms is actually arbitrary. We just chose this because that's our ending argument. So the output of that circuit is supposed to be the input to this, and this is our push-pull amplifier. So our input, we have our input as the output from the Butterworth filter. It cycles through, and then we have our output across here is our 8 ohm speaker.
Over here we have the first part of our project, which is a third order Butterworth filter. We have taken our input from a function generator, and it goes through 3 resistors and capacitors and into the input of the op-amp. And we have the feedback resistors up here that control the gain of our filter. And the output of the op-amp, which is this one, goes to the second stage of our project, which is over here.
Okay, now I'm gonna explain about the push-pull amplifier, which is using an op-amp right here that its VCC value is 5 volts and its VEE value is minus 5 volts. Then it gets the input from the filter. Then BP is connected in a feedback to the voltage divider right here, and this configuration will provide a gain of twice the input. Here we can see the 2 transistors, the NPN and the PNP. The NPN is powered by a 10 volt source, and the PNP is powered by a negative 10 voltage source. Then in this extreme we have the speaker, which is connected to the output of the amplifier.
Okay, we have the function generator here with the 1.1 voltage coming into our Butterworth filter with the first capacitor, and here's being amplified with a gain of 2. We have the, it's the negative 5 volts for the op amp and the positive 5 for the VCC and VE, and it comes over to the push-pull amplifier, which it will be about a 2.2 voltage input for the push-pull because of the 2 gain. And with these, we have these being powered with 10 volts and negative 10 volts for the push-pull, which connects to the voltage divider with the speaker, 8 ohm speaker, which we can turn on right now, and we'll explain the output voltage with different frequencies.
Okay, now we're gonna do the demonstration where we have set up the input signal to be 10 hertz. The amplitude is 2.2 voltage peak to peak. So here we can see that the frequency in the oscilloscope is alternating between 8 hertz to maybe 15 hertz. That's because of the noise present in the signal that you can see is not clear. There is noise in the signal. So we're gonna increase the frequency to demonstrate how the signal is being filtered. So now we're going to 20 hertz, which is still passing, but the voltage in the output should decrease. Now we go to 30 hertz. You can see the change in the speaker also. We go to 50 hertz. We will go to 80 hertz. Then we go to 100 hertz, which is our corner frequency. Then we go to 200 hertz. 300 hertz. At this point, this starts to be really small because it is being attenuated by the filter. So let's go to 1000 hertz. Here you can see that the sound has been already attenuated. Then we go to 5000K, or 5K. Then 10K and 20K, which is like already gone. So I'll turn it off this.
So we have, this is the speaker after it's gone through the low pass Butterworth, third order Butterworth filter and amplified with the push pull. And this speaker is directly from the source. We're using a phone, which is a 1.1 auxiliary port. So you can see we have it split here between the two AC inputs. This one is for the Butterworth, which goes to the filter and amplified, and this is just straight in. And as you can hear already, that's just straight bass. Anything lower than 100 hertz is being pushed through, and just at that point it's quiet. And here we have just the straight song come in. There's that song. You can take this off. Just straight song. Unplug that, plug that back in. Straight subwoofer, I guess you could call it. Straight speaker under 100 hertz type speaker. And that is our third order Butterworth with a push-pull amplifier functioning with music.